About 70% of the planet's surface is made up of ocean basins, which are the regions that are below sea level. These areas hold the majority of the planet's water. In fact, it will help you to recall this term if you remember that a basin is a large bowl, much like your kitchen sink. So an ocean basin can be thought of as a large bowl that holds ocean water. The floors of our world's oceans contain features that you might recognize as being similar to some structures on land. In this lesson, you will learn about these features, including undersea mountains and trenches, and how they are formed. Ocean basins can be either active, with a lot of new structures being created and shaped, or they can be inactive, where their surface is slow to change and does little more than collect sediment. The Gulf of Mexico is an example of an inactive ocean basin, where the main change that happens is the slow depositing of sand and sediment. Active ocean basins undergo change mainly due to plate tectonics. Plate tectonics is the theory used to explain the dynamics of the Earth's surface resulting from the interaction of the overlying rigid plates with the underlying mantle. According to the theory, the Earth has a rigid outer layer called the crust. This crust is somewhat fragile, and like the shell of a hard-boiled egg, it can crack and break into plates. The Earth's crust breaks due to heat and pressure from the layer beneath the crust called the mantle. These plates move very slowly and meet at their boundaries. These boundaries are common areas of tectonic activity, which is the deformation of the Earth's crust due to movement of tectonic plates resulting in activity such as earthquakes, volcanoes, and mountain building. So an area of the world that is tectonically active, whether it be on land or under the water, would be a mountainous area with earthquakes and volcanic activity. This creates many of the ocean basin features. Plates can spread apart by moving away from each other. This creates gaps where hot molten rock, called magma, from the Earth's mantle can rise up. When the magma seeps through the gaps, it solidifies as it cools, creating a new layer of ocean crust. This creates structures such as oceanic ridges, which are continuous mountain chains located under the surface of the sea. You can think of their creation in much the same way as a scab gets created over a wound. For example, when you cut your finger, it bleeds. The blood flowing out of the cut relates to the magma flowing out of the gap between the spreading plates. The cut will form a raised scab on your finger, and as the magma cools, it will form a raised layer of crust on the sea floor. An abyssal hill is another raised feature found within ocean basins. It is defined as a small elevated landform that rises from the great depths of the ocean. It might help you to recall this term by remembering that an abyss is something that is very deep. So an abyssal hill is a hill found on the deep ocean floor. An abyssal hill has sharply defined edges, but will remain relatively small, generally growing not much larger than 500 feet in height and a few miles in width. A seamount is a large submerged volcanic mountain rising from the ocean floor. Seamounts can be very large, reaching heights of up to 10,000 feet, yet they remain submerged under the surface of the water. A guyot is similar to a seamount, but it is a submerged volcanic mountain with a flat top. Guyots receive their flat top after years of erosion caused by waves and other erosive processes. We have looked at some ocean basin features that rise up from the ocean floor, but we also see depressions in the ocean floor, such as oceanic trenches. These trenches extend down below the normal level of the ocean floor and are the deepest parts of the ocean. Unlike oceanic ridges that form when plate boundaries separate, oceanic trenches form when plates push together. When plates abut up against each other, one plate subducts or slides under the other, carrying rock down into the mantle where it is heated and can melt. This can increase volcanic activity near oceanic trenches. Trenches vary in depth, with the deepest oceanic trench being the Mariana Trench in the Pacific Ocean, which reaches a depth of over 36,000 feet. Let's review. Ocean basins are the regions that are below sea level. They can be either inactive and collect sediment, or be active. Active ocean basins undergo changes mainly due to plate tectonics. Plate tectonics is the theory used to explain the dynamics of the Earth's surface resulting from the interaction of overlying rigid plates with the underlying mantle. These plates, found on the outer layer of the Earth, can move and meet with other plates at their boundaries. These boundaries are common areas of tectonic activity, including mountain building, earthquakes, and volcanoes, and the areas where ocean basin features are created. When plates spread apart, they create gaps where magma from the Earth's mantle can rise up and cool to form structures such as oceanic ridges, which are continuous mountain chains located under the surface of the sea. An abyssal hill is a small elevated landform that rises from the great depths of the ocean. A seamount is a large submerged volcanic mountain rising from the ocean floor, and a geo is a submerged volcanic mountain with a flat top. Oceanic trenches are depressions in the ocean floor. Oceanic trenches form when one plate subducts or slides under another.